Okay, so it is due to this balance force or component of the weight, the reason for which we say the reactional force R is equal to mg cos theta. So when there is no friction, when friction comes in, friction would oppose the motion. So whilst the mass rolls down the inclined plane, friction will act in a direction opposite to the direction of the unbalanced force. So once it's frictionless surface, smooth, frictionless surface, then the only force acting along the plane is mg sine theta. So that's the resultant force. The resultant force acting down the plane is equal to mg sine theta. Let me mute all so that I can have mg sine theta. Therefore, if I want to calculate the acceleration of the body down the plane, acceleration of the body down the plane. Oh, don't worry, I'm just building up, so you understand. So, if I want to calculate the acceleration of the body down the inclined plane, then using Newton's second law, Newton is saying acceleration of a body is equal to the force divided by the mass. Okay, so the acceleration of the body down the inclined plane will be equal to the resultant force mg sine theta divided by the mass. Mass will cancel out, and so the acceleration is given by g sine theta. So the acceleration of the body down the inclined plane is a product of gravity, acceleration due to gravity, and then the sine of the angle of inclination. And this is when we have only the unbalanced force acting down the plane. Now, let me create situations. So let's look at what force. Okay, let's look at the applied force which can stop the body from rolling down the plane. That applied force which can stop the mass from rolling down the plane. Okay, so we want to this time look at that amount of force when applied would stop or will keep the mass at rest. So what applied force can keep the body or the mass at rest? On the plane. So the question is such that always, without any force, an inclined plane body on an inclined plane is rolling down the plane. So what is that amount of force when applied, and the force which will keep the mass stationary on the plane, will it act against the unbalanced force or in the direction of the unbalanced force? Class, we are looking at a force which will keep the mass at rest on the plane. Now, that force, when applied, must the force act against the unbalanced force or in the direction of the unbalanced force? Anybody? That force which will keep the mass in position or at rest, when applied, will the force act against the unbalanced force or in the direction of the unbalanced force? Yes, I need somebody to. Yes, Pascaline.
Against the unbalanced force.
Exactly. So it must act in a direction against the unbalanced force if you want to keep it at rest. So it must act in this direction. Now, for the body to stay at rest, what must, Pascal, mute yourself. What must be the relationship between the unbalanced force and P? For the body to remain at rest, what must be that relationship between the unbalanced force and P? Anybody? Calvin, Dodu.
Please, P and the unbalanced force must be the same.
Must be the same. And this is due to...
They must be the same.
They must be the same or equal. And this is due to what theory? This is due to what theory? Can you tell me the theory behind just why the unbalanced force and the applied force P must be the same? What theory says that? Oh, class, quick. What theory, says, yeah, it's justice.
Newton's first law of motion.
Newton's what?
First law of motion.
Newton's first law of motion. Good. For a body to be stationary, the net force acting in all directions must be equal. So if you want the body to be stationary along the inclined plane, then the applied force here, P, must be equal to the unbalanced force mg sine theta. And when they are equal, the body will stay stationary. Now, for the body to move up the plane, for the body to accelerate up the plane, what must be the inclined plane? What must be the applied force? What must be the relationship between the applied force and the unbalanced force? Let me call individuals to also contribute. For the body to accelerate up the inclined plane, what must be the relationship between the applied force and the unbalanced force? Yes, and here, let me call on, yes, Dodo, no, Pascaline and Dodo, relax for some time. Let me go to...
Is the applied force represented with P or F?
Yes, P. So let me invite, please, when I call you, you must talk. Oh, you must talk. I'm going to call, okay, Franca, help me. Hey, Farida, are you also here? Franca. Hey, Zion. Okay, Zion, your time will come. Yes, for the body to accelerates up the plane, what must be the relationship between the applied force P and the unbalanced force? Franca. Franca, are you there? Okay, Inshiraminta.
Please, the applied force must be greater than the unbalanced force.
Exactly. So the applied force, for the body to do this, the applied force P must be greater than the unbalanced force, mg sine theta. Now the difference between them, the difference between the
Why?
Farida, mute yourself. The difference between the applied force and the unbalanced force would be equal to what? Farida, you were talking. The difference between the applied force and the unbalanced force must be equal to. Farida, I've called you. The difference between the applied force and the unbalanced force must be equal to what? Okay, maybe Farida is still thinking about it. So Zion, are you there? Zion. Hey, Zion is not there. Okay,
Yes,
anybody?
please, I'm here.
Zion, the difference between the applied force and then the unbalanced force must be equal to what? Okay, Zion is still thinking about it. Justice. Okay, Ejiwa. Justice, let me give the chance to Ejiwa to also talk. Hey, Ejiwa.
Sir, please, I think it's the net force.
Thank you. So the difference between the applied force and the unbalanced force must be equal to the net force. Okay, so the net force, which is actually causing the acceleration, would be equal to the applied force P minus the unbalanced force mg sine theta. So if this is the applied force, this is the net force, I want somebody to help me determine the acceleration. What will be an equation representing the acceleration of the body in this case? Start work. So put pen on paper, derive an equation for the acceleration of the body. If this is the net force. 2 minutes. After 2 minutes, I'll call you to share. Dodo, Calvin, put your idea down. After the 2 minutes, I'll call some of you to share what you have with me. If the net force is the applied force P minus the unbalanced force, what will be an equation representing the acceleration of the body up the plane? Let me look for a question. Always try right up. Are we done? Okay. All right. Justice, what is your answer for acceleration of the body up the plane?
I thought you said we should get the formula.
Yes, the equation, your formula, okay.
A is equal to unbalanced force minus applied force over mass.
look at it again. This is our net force. We agree that for the body to go up, the applied force must be greater. So look at it again. Okay, Kelvin. Kelvin, your line is breaking. No. That Franca. Franca. Yay. Yes, let me hear from you.
Please, the acceleration will be P minus mg sin theta.
Exactly. So P minus mg sine theta all divided by the mass. Okay. So that will be the equation for the acceleration when the body mass accelerates up the plane. Let's look at the question that was put on the platform. Please mute yourselves. Mute yourselves for me. Okay, so the question I gave you was that a body of mass 5 kilogram is placed on a smooth plane that is inclined to the horizontal at an angle of 30 degrees. It's on the page. Let me repost it perhaps to those of you who could not. Yes, a lot of you tried and your answers were forwarded to me. So those of you who couldn't do it, I think at least you can have this opportunity to also go through it. So this is a question. A body of mass 5 kilogram is placed on a smooth plane that is inclined to the horizontal at an angle of 30 degrees. Calculate I, the reaction force perpendicular to the plane, II, the resultant force acting down the plane, and III, the acceleration of the body. The acceleration of the body. Take G to be equal to 10 meters per second squared. Okay, so this question has to do with the first scenario where there is no applied force in the opposite direction, but only the unbalanced force acts on the body. And don't forget, it is a smooth inclined plane, meaning friction is considered to be very, very minimal or zero. Okay. So our first question requires that we calculate the reaction force perpendicular to the plane. And we know reaction is always balanced by the component of the weight, which is perpendicular to the inclined plane, mg cos theta. So this is what will help us calculate the reaction. So the mass 5 times acceleration due to gravity, which is 10, and then cosine of the angle of inclination, which is cos of 30 degrees. So we have 50 times cos 30 is equal to root 3 on 2, which is approximately 0.866. So 50 times 0.866, this will give us 43.3. So if you got that, please start marking yourself. Start marking. Then the second question, the resultant force acting down the plane. The resultant force acting down the plane. So I. The only force acting horizontally along the plane is the unbalanced force. So that's the resultant force. So resultant force will be equal to mg sine theta. And this is 50 times sine of 30 degrees. Sine 30 is half. So 50 times half, we have 25 Newton. And then the last question, the acceleration of the body down the plane. Okay, so acceleration is direct proportional to the resultant force. So using Newton's second law, F is equal to ma, and if F is 25, then A is equal to F over m, which is 25 on 5. This is equal to 5.0 meter per second squared. Another way out, once the unbalanced force is the only force acting on the body, we can also say that its acceleration is equal to J times sine 30 degrees, and gravity is 10, sine 30 is half, and the value is the same. Class, are we okay? Class, are we fine?
Yes, sir.
Yes.
Is there any question? Isaac Wilson.
Yes. Please, at the left side of the page, you wrote A is equal to J sine theta, but when you were solving it, you didn't. Okay, sir. So please, I found it. Thank you, sir.
Okay, welcome. So I'm going to modify the same question. What if there is friction on the surface? And don't forget, friction would always act against the direction of motion of the object. So if the object is rolling down, we expect friction to oppose it in the opposite direction. So the same set of questions, but we are told that the coefficient of static friction on the surface is 0.2. So that's the only modification. This time around, there is friction on the surface. There is friction on the surface. So calculate after the normal reaction, the value will be the same. So we look for II, the resultant force acting on the body. The resultant force acting on the body, and III, the acceleration of the body in this particular case. So class, we are modifying the same question. The addition is that one, we are to find the resultant force acting on the body when there is friction. And two, the acceleration of the body when there is a consideration of friction. Okay, and let me add a third one. We are to determine the length of the plane, the length of the inclined plane, when the height of the plane is 1.5 meters. Calculate the length of the plane if the height of the plane is 1.5 meters. Okay, so start work. Let's see how you can wear your thinking caps when there is this slight modification. I'll come to you after 6 minutes time. It's 2:05. So at exactly 2:11, I'll come your way. Start work. Please, you can share ideas, discuss. Let me hear you discussing. Okay, start work. And problem of the afternoon. I repeat the same question. This time we are factoring friction, and the coefficient of friction, starting friction on the surface is 0.2. Calculate the net force acting on the body and the acceleration of the body and the length of the inclined plane. All the best to you. 3 minutes more. 3 minutes. Two minutes. 2 minutes more. 2 minutes more. Okay. A minute more. A minute more. So theta is 30. Meaning the angle here would also be 30. So this time we have to calculate the resultant force. Resultant force when there is friction. And I, as the acceleration of the body. And I, the length of the plane. Okay, so whilst we go through it, you mark yourselves. If you get it correct, you mark it correct. Wrong, you mark it wrong. Okay. So the resultant force when there is friction, so rough on a rough inclined plane, still the body would accelerate down, meaning the unbalanced force will still be greater than the frictional force. Therefore, the resultant force when there is friction will still be mg sine theta minus frictional force. And friction we know is equal to the coefficient of static friction times the normal reaction. And since normal reaction R is equal to mg cos theta, we'll have this to be mu mg cos theta. So let's find the friction. We already have calculated the unbalanced force mg sine theta. So F would be equal to 0.2 times 50, the mass is 5, gravity is 10, times cos of 30 degrees. Okay. And so 0.2 times 50 will be, what is 0.2 times 50? Class, 0.2 times 50.
10.
So 10 times 0.866. And this is giving us 8.66 Newton for the friction. Therefore, the resultant force would be equal to, what is the value of mg sine theta? What did we get for mg sine theta?
25.
Class, come again.
25.
So 25 minus 10. So it means that the resultant force when friction acts against it will be 15 Newton. If the resultant force is this, then the acceleration, which is equal to F over mass, would be equal to 15 divided by 5. And that is 3.0 meter per second squared. So class, let me see by hands, those of you who got, yes, hello.
But so I thought you subtract 8.66 from the 25. You rather subtracted 10.
Oh, okay, thank you. I rather subtracted 10. So 8 point, thank you for the feedback. So 8.66. So 25 minus 25 minus 8.66, that is, hello, I'm listening. 25 minus 8.66.
16.34.
16.34 Newton, and that is the resultant force. Okay, therefore, the acceleration would also change. (16.34) divided by 5. Class 16.34 divided by 5.
3.26.
26 meter per second squared. And that's the value of the acceleration. Please show by hands if you got this correct. If you got everything correct, let me see you. If you got everything correct. So Francis, Jose, Papa Kujo. Oh, only the two of them. Oh, okay. So class, this is how to go about it. That is I and I. Then the length of the plane. The inclined plane here shows a certain right-angled triangle. It shows a right-angled triangle. And so we use trigonometry. You have justice.
Sir, please, there's no light off here, and my phone is gone low battery. It's left
I'm
at
recording.
1%.
I'm recording it. Don't worry.
Sir, I was asking for permission because I don't know the time though on it, and the phone is
Okay.
1%, so it will off right now.
Well taken. Okay. Thanks for the permission.
Okay.
Yes,
Okay,
Alexander, it's good. It's good to be sincere. Yes, thank you. So the length of the plane, when you have the opposite, you have the angle of inclination, and so you can easily determine the length. O, A, B. So the length of the plane is OA. Therefore, when I take sine of the angle of inclination, sine 30, just this again.
Yeah, sir, please, I'm getting a power bank, sir.
Oh, okay. So sine 30, which is equal to the opposite. The opposite is the height of the plane divided by the hypotenuse, and that is the length. Okay. So the length, when we make L the subject, we have H over sine 30. Sine 30 degree. And H is 1.5. Sine 30 is 0.5. So what is 1.5 divided by 0.5? Yes.
3 meters.
Come again.
3.
3. Good. So that's the length of the inclined plane. So simple. Okay. All right. I'm giving you another one to try. Another one to try. So please listen. A body of mass m kilogram, m unknown. A body of mass m kilogram is placed on a smooth inclined plane of an angle of 42 degree to the horizontal. A body of mass m kilogram is placed on a smooth inclined plane of an angle of 42 degree to the horizontal. Full stop. The normal reaction perpendicular to the plane is 14.9 Newton. The normal reaction perpendicular to the plane is 14.9 Newton. Calculate the mass M. Calculate the mass M of the body. Calculate the mass M of the body. Can you hear me?
Yes.
Then AII. The force parallel to the plane. The force parallel to the plane that is needed to hold the body at rest. The force parallel to the plane that is needed to hold the body at rest. That is AII. B. If the body is pulled up the plane, if the body is pulled up the plane by a force 20 Newton, if the body is pulled up the plane by a force 20 Newton parallel to the plane, if the body is pulled up the plane by a force of 20 Newton parallel to the plane, find I, that's BI, the resultant force along the plane. Find I, the resultant force along the plane. II, the acceleration with which the body moves. II, the acceleration with which the body moves. Take G to be 10 meters per second squared. Take G to be 10 meters per second squared. I'll equally drop this on the page. So if you miss some parts, you can pick it on the page, okay? I've dropped the question on the page. A body of mass m kilogram is placed on a smooth inclined plane of an angle of 42 degrees to the horizontal. The normal reaction perpendicular to the plane is 14.9 Newton. Calculate AI, the mass m of the body. Then II, the force parallel to the plane that is needed to hold the body at rest. Then B, if the parcel is pulled, the parcel is the body. So if the parcel is pulled up the plane by a force 20 Newton parallel to the plane, find I, the resultant force along the plane. II, the acceleration with which the body moves. Take G to be 10 meters per second. So give it a try for, I think 7 minutes will do. It's 2:30. So 2:37, I'm coming your way. All the best. So we have 1 minute to go. 1 minute. Just a minute to go. All right, I think it's time for us to look at the question. So let me take your answers before we all solve the question. You were asked to calculate for determine the mass. Determine the mass. What is your answer for the mass of the body? Yes. Alexina, what is your answer for the mass? The mass of the body?
Please, I had 2 kg.
2 kg.
2
Exactly
kilogram.
2.
Yes, please.
Okay, Osai Papa Kojo.
So I also had 2 kg.
Okay. The math, I think, is easier. Franca, did you get 2? Did you get 2?
Sir, please, I got 2.04 kg.
005.
2.04 kg.
2.04. It must,
Kg.
okay, it must be around, I think, 2.005, which is approximately 2. Okay, so concerning the mass, once we have the reaction, it must be easier. The normal reaction is 14.9 Newton. And we know R to be equal to mg cos of theta. Well, it means that 14.9 is equal to mg. And we're given J to be 10. Then the angle of inclination is 42. So cos of 42. The rest is mathematics. M must be equal to 2.005 kilogram, approximately 2.0 kilogram. All right, so I think those answers you shared are all correct. Then the force parallel to the plane that is needed to hold the body at rest. So since it is a smooth inclined plane and the only force acting on the body is the unbalanced force mg sine theta, to keep it at rest, the applied force must be equal to the unbalanced force. So the applied force must just be equal to mg sine theta. Therefore, we have 2 times 10 times sine of 42. Give me the product of this. 20 times sine 42. Class, 20 times sine 42. Speak up or I beg you.
13.4.
Is it 13 or 14?
13.
Okay, so 13.4 Newton must be the applied force, which when applied will keep the body stationary. Then B. If the body or the parcel is pulled up by a force 20 Newton parallel to the plane, find. So this time around, we are giving the applied force. The applied force, don't forget, A is different from B. Okay, so we are to find the resultant force along the plane. So once there is an applied force pulling it up, then it means the resultant force must be the difference between the applied force and then the unbalanced force. So 20 minus the unbalanced force, 13.4 is the same mass. Okay. So that would be what? 6.6.
5.
No, it's 6.6.
6.6 Newton. 20 minus 13.4. Are we okay?
Yes, sir.
Okay.
Yes,
Then
please.
the acceleration. Acceleration is equal to the resultant force divided by the mass.
Mass.
And that will be 6.6 divided by 2. And that will also be 3.3 meter per second squared. Let me see by hands those of you who scored everything. This time I want to see more hands. So okay, 9 hands, 10, 11. Okay, 12. That's good to know. All right. If along the line you made any mistake, I'm sure you have figured out where you went wrong. Class, is that the case? Those of you who committed 1 or 2 mistakes. But if you have any question, please quickly ask so we can continue. Is there any question? All right. Emmanuel.
Sir, please, the questions you gave us right now, the answers that you gave, I don't understand the way you got the this.
I got which one?
The applied force.
Oh, the applied force was given to us. Listen to the question. If the parcel, the body is pulled up the plane by a force 20 Newton parallel to the plane. So we are told that the body is being pulled up. So let me draw. Supposing this is the body. This is the inclination 42. We know on an inclined plane, there is always unbalanced force mg sine theta here. Okay, so if the body is being pulled up the inclined plane by a force of 20 Newton, calculate the net force. So the net force will be the difference between 20 Newton force and then the unbalanced force. Okay, and so once we have, don't forget the mg sine theta, we got 13.4. So this is 13.4. And so the difference between 20 Newton and 13.4 is the net force, which is actually pulling the body up. And once you have the net force, the acceleration is obvious. Please, are you okay? Class, are we fine? Yes, Emmanuel again.
Please, it is the old hand.
Okay, Inshira, quick one.
So, sir, is a formula for the resultant force and the net force the same?
No, you see, the resultant force, net force and resultant, you see, net is the net force is the difference between two forces. So here, because horizontally we have the applied force and then the unbalanced force, we will call it as the net force. There's the difference. And it's the same as the resultant force. Resultant means the result of the action of a number of forces. So when two forces act in opposite direction, what is the result? The result is the resultant force, which is the same as the net force. So I'll say yes to your question. Are you okay?
Thank you, sir.
All right.
Yes, sir.
So let's then look at equations of motion when a body is rolling up or down an inclined plane. We have equations which are used to calculate the distance and all that on an inclined. Farida.
Sir.
Mm-hmm.
Sir, please, back to the question, the A. I still don't understand how you got the resultant force.
Okay.
So how you got the mass?
Oh, the mass, you see, Farida, we're given the reactional force, 14.9. We're told that the reactional force acting on the body is 14.9. And we know that on an inclined plane, the normal reaction is equal to mg cos theta. So we have R. R is 14.9 Newton. So 14.9 is equal to the mass, which is unknown, times acceleration due to gravity 10 times cosine of the angle of inclination, cos 42. So input, what is cos 42? Farida, give me the value of cos 42 in 3dp. Cos 42. Do you have your calculator with you? Farida, do you have your calculator with you? Farida is not there.
Sir, please, I'm here.
I said, give me the value of cos 42 in 3dp.
Sir, 0.743.
0.743. Okay.
Yes.
So 10 times 0.743, you have 7.43 m. So divide through by 7.43. Divide 14.9 by 7.43. Are you following what I'm doing on the screen?
Yes, please.
So follow and give me the value of m. Give me the value of m.
Say 2.005.
So that's the value of the mass.
Okay.
So we said we rounded it up to the nearest whole number. So it's 2.0 kilogram. That's how we got the mass. Please, is there any other question?
Say thank you.
Welcome. Is there any other question? Isaac? You have network fluctuation. Okay. So equations. Okay. Equations of motion for a body rolling along an inclined plane. But this is applicable to only frictionless surface for frictionless smooth inclined plane. Frictionless surface. When the surface is frictionful, we don't apply. You see, we earlier derived a relation which says that if the only force acting on the body is the unbalanced force mg sine theta, then the acceleration of the body is given by j sine theta. So when the body is rolling down the plane, recall linear motion equation. Equation 1, V is equal to U plus AT. Equation 2, S is equal to UT plus half AT squared. And 3, V squared is equal to U squared plus 2AS. Okay, so for motion along an inclined plane, we are only representing the acceleration A by acceleration of an inclined plane. And so equation 1 becomes V is equal to U plus J sine theta T times T. And S is equal to UT plus half J sine theta times T. And V squared is equal to U squared plus 2 J sine theta times S or H. These are the equations of motion on an inclined plane. And when the body is rolling, going up, the acceleration becomes negative. That is all. So when you understand acceleration in this case, when this is the only force acting on it, you can easily, it is actually most often applied to rolling down, because for a body to go up, there must be applied force. So we wouldn't have only the mg sine theta bringing it. Okay, so it applies to rolling, mostly applies to when the body is rolling down the plane, because if the body must go up, then you must apply a force, and the resultant force wouldn't be mg sine theta. So this brings us to the end of inclined plane. I want us to start vertical motion under gravity. Tomorrow we'll continue, or after the test, we'll also continue and quickly finish that. And then we begin with heat and light and all that. Okay. So if there is no question, can I start? Isaac.
Sir, please, can you move on to the previous slide?
Yes,
Sir,
I'm
please,
there.
so no, the one that comes after this one, the one with the equations of motion.
Yes.
Sir, please, I realized that the equation of motion for the second equation, when you made it for the inclined plane, the square of the t disappeared. Sir, please, why is that?
Come again. Oh no, it should be there. T must be squared. Thank you. T
Okay,
must be
sir, thank
squared.
you.
See, the only substitution we are doing is the A acceleration equal to g sine theta, but the rest must appear. So thanks for the correction.
Okay, sir.
Okay, so motion, vertical motion under gravity. Vertical motion under gravity. We have moved up, out linearly along the floor or the ground. Let's look at when an object is shot to go up or projected. So vertical motion under gravity. Before an object would go up, you cannot hold an object, then it will start going up by itself. Before the object will go up, there must be a force applied to the object. So if this is the ground and you have an object in your hand, for the object to move up, you must apply a force to it. Applying the force gives the object a certain initial velocity. So before an object will go up, there must be an initial velocity given to the object. And this initial velocity is provided by an applied force. However, as the object continues to go up, what happens to the speed of the object? As the object continues to move up, what happens to the speed of the object, which is initially given to the object? Emmanuel.
Please, sir, it reduces.
So the speed will reduce. So let's assume, okay, so let's assume the initial velocity given to the object as a result of the application of the external force is u. At 2, we have u, so u1 here, then we have u2, u3, okay? You realize that u2 will be less than u1. Then u3 would also be less than u2. As the object goes up, its speed decreases. And this drop in the object speed is due to what? Is due to, let me hear from all of you. This drop in the speed is due to
Gravity.
Gravity, yes. Okay. And so when a body is moving and the speed or velocity continues to decrease with time, we say the object is decelerating. So when an object is thrown to go up, the body or the object decelerates due to gravity. So a vertically upward object or body, a vertically upward moving body decelerates due to gravity. Due to gravity. Okay. So the object will decelerate, and at a certain point in its flight, the velocity would be reduced to 0. When the at the point or at the time where the velocity is 0, the object is said to have reached its maximum height. So the object, when projected to go up, will reach its maximum height at the point or at the time where its velocity is reduced to 0. Are we okay? At the point where, so when the final velocity of the object is 0, the object is said to have reached its maximum height. So look at the footballers. Whenever footballers are playing on the turf, no matter how hard the keeper would hit the ball to go up, the ball will never remain in the air forever. It will go and come, because as the ball goes up, its speed will be decreasing, and there will be a point where the decreasing speed will be reduced to 0, and this drop in the speed will naturally happen because of gravity. Okay, so by the time where the ball just begins to drop up, then its speed or velocity has decreased to 0, and it will definitely come down. Okay, so nothing, so long as gravity is there, nothing will stay in the air forever. All right, please, is there any question? Then let's quickly look at vertically downward motion. So when the object is going up, the body decelerates, meaning its speed decreases, and this is due to gravity. What of if it is coming down? So vertically downward motion. Let's look at downward. So vertically downward motion. And here we are looking at a body that is falling freely, or a body in free falling or in free fall. What we mean by free fall is that, look at orange or a mango attached to the stalk. When the stalk breaks down, as at the point, or as at when the stalk is intact, the body is at rest. At this position, the initial velocity of the body is 0. When the stalk breaks, when there is a break, the body would fall freely. And here, falling freely means that a body is falling in such a way that gravity is the only force acting on the body, or gravity is the only unbalanced force. It's not balanced. Gravity is not balanced. So gravity is the only unbalanced force. All other forces are balanced, so they have no effect. But gravity is the only unbalanced force acting on the body. And this is what we refer to as free falling. Class, are you there?
Yes.
Okay, so Wilson, when we say that a body is free falling, what does it actually mean? When a body is said to be free falling, what does it mean?
So please, it means that gravity is the only force acting upon the body and the other forces are all balanced.
So gravity is the only unbalanced force acting on the body. Okay, then the body is in free fall, or the body is free falling. So here, the initial velocity is 0, free falling. When it gets to 2, the velocity, so when it is free falling, the velocity is increasing. So this time around, we have increasing velocity or speed. So the velocity of the body at 1 is less than the velocity of the body at 2. Okay, at 2 is also less than at 3 on, and by the time the body hits on the floor, the body falls with a maximum velocity. Okay, by the time the body hits the floor, it falls with a maximum velocity. Don't forget, when it hits the floor, it has come to a stop. So the velocity is 0. So we are looking at when the body just hits the floor, it is falling with a maximum velocity. So in this particular case, or vertically downward motion, the body accelerates. And this acceleration is due to our old friend gravity. So upward motion, the body decelerates. Downward motion, the body accelerates. Ladies and gentlemen, I hope you are following me. Ladies and gentlemen, let me hear from you. Okay.
Yes,
Emmanuel, your hand is still up. Is it the old hand?
Yes, sir.
Okay. All right. So that is it with vertically upward and downward motion. There are some interesting equations to this effect. So we are about 6 minutes to time. Okay. All right. So let's wrap up what we are doing. We've learned about free falling. Free falling. A body is said to be free falling when gravity is the only force that acts on the body, or when gravity is the only unbalanced force acting on the body. Here, in the absence of all other forces, such as air resistance, friction, of course, air resistance and friction in the air. Okay, so all other forces are out, but only gravity is the protagonist of this movie. Okay, so that is free falling. And when a body falls freely, the body falls with a constant acceleration of approximately 10 meters per second squared. And that's the value of acceleration of gravity we've been using when a body is within the gravitational field. So when the body falls freely, the body falls with a constant acceleration of 10 meters per second squared. What this value actually means is that the body changes speed of 10 meters per second within every second. So if the body is falling with an acceleration of 10 meters per second squared, it means that its speed changes by 10 meters per second within every 1 second. The change in its speed with respect to time is 10 meters per second within every 1 second. Class, are we okay? And when a body falls freely, during free falling, that is the only time where no matter the mass or the weight, two bodies must drop at the same time. So when you pick a cotton ball or cotton wool and hammer or stone or even feather and hammer, when you drop them at the same time, under the condition of free falling, feather and hammer are expected to fall at the same time. It doesn't matter the weight or the mass. Does it sound controversial to you? Farida?
Yes, sir.
Does my my statement sound controversial to you?
A bit.
When I give a condition, the condition is that the body is free falling. When two bodies of different masses, so go and carry a very big stone and then cotton wool, small cotton, just cotton, and drop them at the same time. If the body falls, if the two bodies are under a condition of free falling, then the two bodies are expected to drop at the same time, simultaneously. This is because, remember, I said free falling is when gravity is the only force acting on the body in the absence of all other forces. So Farida, air resistance is not here. It is only gravity acting on them. And when you have absolute situation of this nature, the bodies are expected to drop at the same time. Please, is there any question?
No, please.
All right. So this is the concept of tomorrow we would continue with equations of motion and all that. And in fact, this is also an interesting area to study. Okay. So I'll leave you. We have just a minute. We have just a minute to end. I'll give you 1 minute freely to use for revision in order to effectively handle tomorrow's test. Okay, class, this is where I end today's show. Okay, please, I'll upload the video as usual. If you don't have any question, bye-bye and see you tomorrow.
Bye.
All right. Okay. Today, it seems the blackboard cleaners are not here. Thank God they are absent. You people.